Today we're going to walk through 3 basic triangle proofs just to review some of the reasons for proving triangles congruent and to write down a couple of them that we haven't used for a little bit. So here we have a triangle with a line down the middle, and we are given that PE is congruent to PU, angle 1 is equal to angle 2, and 3 and 4 are a linear pair. So the first thing I like to do is mark up my diagram. PE is congruent to PU. That means we want to put our markings in there to show that they're congruent. And then angle 1 is congruent to angle 2. We're going to mark those. Those are supposed to be arcs. So they're congruent. And 3 and 4 is a linear pair. What we want to eventually get to is the fact that PR is perpendicular to EU. So to do that, if I'm going to prove that they're perpendicular, we already know they're a linear pair. So if they're a linear pair, and if I can show that they are congruent, then they have to be perpendicular because both sides would have to add to 90 degrees. So that's what we're going to do. And we have our statements and reasons down here. We've got our givens, 2 of them here. Notice that my third given I don't put in until step 6. You don't have to write them all at the beginning. You can kind of use them as you go. The next reason is PR is congruent to PR. And almost everybody will pick up on the fact that that is our reflexive property. So that's reflexive. I'm going to write this as neatly as I can in here, which isn't very neat today. And that's enough. When you look at it, we've got angle, side, angle to prove those triangles are congruent. So that's angle, side, angle. After that, once we get the triangles congruent, and this is almost always the case, I can go back and say that corresponding angles of congruent triangles are congruent. So that's C, P, C, T, C. We always have to get a triangle congruence before we can get CPCTC. Once you have that, it's given that we have a linear pair, and we can now say that PR is perpendicular to EU because congruent linear pairs, as best as I can here, are perpendicular by definition. So the next proof we're going to do is a short one, just 4 steps, and I just want to show you some reasons to prove that a triangle is isosceles. We are given this time, we're going to save some steps here because we're given the fact that the 2 triangles are congruent. And when you have 2 triangles congruent, you have to look at the correspondence. So angle B is going to correspond with angle C, U with N, and then N with U. Okay? So, or angle BUN with CNU. So when you do this, you have your 2 overlapping triangles, and the next step is to say that angle 2 is congruent to angle 3. Angle 2, if you look at this, because we have the overlapping triangles, angle 2 is part of triangle CNU, and angle 3 is part of triangle BUN. So those 2 are congruent because corresponding parts of congruent triangles are congruent. Okay, so after that, we can also say that HU is congruent to HN. And here's why we can say that. Because I have the angles in this center triangle congruent. So triangle HUN, that triangle has the base angles congruent. And when base angles are congruent in a triangle, the sides opposite the base angles are congruent. So that's the reason we use side in a triangle, sides opposite congruent base angles are congruent. And that's enough to say that the triangle is isosceles. Now, in some cases, some textbooks will have you just start with base angles are congruent, but the actual definition of an isosceles triangle is a triangle with two congruent sides. So that's what we have shown here, that the two sides are congruent. Therefore, HUN is isosceles by definition of an isosceles triangle. So now let's look at our third proof. We're given that angle 1 and angle 2 are vertical angles. So here they are, and we can see that they're vertical angles. I'm not even sure if we actually have to have that given to us. We're given that angle 3 is equal to angle 4, and BH is congruent to HC. So I'm going to mark up my diagram. BH, HC, angle 3, angle 4. And I'm trying to prove that BHI is congruent to CHR. So if you look at that, these angles are not part of those triangles. So we're going to have to do something different there, but we already have a pair of sides, and with vertical angles, we can get the angles, and then we'll talk about what we're doing. I guess the first step is dealing with the other side. So if I have these two angles congruent, that means I have a triangle here, and I can go back and say that these sides are congruent. The same reason that we used in the last proof, that in a triangle, sides opposite congruent angles are congruent. In a triangle, the sides opposite congruent angles are congruent. And then we're given that 1 and 2 are vertical angles, so we can say angle 1 is congruent to angle 2 because vertical angles are congruent. We're given that BH is congruent to HC, so that's enough now to say that the two triangles are congruent because of side, angle, side. So that's just another reminder of some of the reasons that we use in proofs. And I just put in a couple that we haven't used recently. Again, in a triangle, sides opposite congruent angles are congruent. Vertical angles are congruent, and the other one, congruent angles that are linear pairs are perpendicular. So we'll practice more of these things in class.